We learned earlier that ln of x prime is 1 over x, but I did not explain why this is so, because to understand this we need the chain rule. Now we know the chain rule. I can explain why this is true, and the reason this is true actually relies on the fact that e to the ln of x, because e and ln cancels, is the same thing as x. And this is really an identity. It's true for any value of x, right? As long as x is in the domain of ln, so if x is positive, these two sides are equal. Now, when two sides are equal for infinitely many values in an interval, then that's called an identity. There's a difference between an identity and an equation. So let me explain that. X plus 1 squared is x squared plus 2x plus 1. That's an identity. That's always true, whether x is 0 or 1, or just pick your any value. You'll see that the left side and the right side evaluate to the same value. On the other hand, say 3x plus 1 equals to 4. That's an equation for x because it's only true for one or maybe a few values. Like quadratic equation might have 2 solutions, cubic equations might have 3 solutions. But those are true not in an interval. It's only true for some finite values, right? And the big difference is if you differentiate both sides when it's an identity, then their derivatives are also equal. See, you can differentiate this left side by using the chain rule. Think of x plus 1 as big X, x squared is 2x, x squared differentiates to 2x, but x plus 1 is what we covered. And you have to multiply by the derivative, but the derivative of x plus 1 is 1. On the other hand, this is x squared differentiating to 2x, 2x differentiates to 2, and we have this, and indeed this is true, right? If you multiply this out, indeed the left and right side are equal. So that's okay. Whereas, if you have an equation, differentiating doesn't guarantee their derivatives to be the same. Sometimes by luck they might be equal, but in most cases they're different. So if you differentiate 3x plus 1, you get 3, whereas if you differentiate 4, that's a 0, so they're different, right? So that's like the big difference between an equation and an identity, and as long as you have an identity, you're allowed to differentiate both sides, and they're going to give you the same answer. Okay, back to this. If you're convinced that this is true for, say, x equals to 2, 3, any value, then now you're allowed to differentiate. The right side is very easy to differentiate. It's just 1. And this left side, you can differentiate it by the chain rule, right? Think of ln of x as the big X. Differentiating that means you first cover ln of x as a big X. Derivative of e to the x is e to the x. And you uncover the x, write it as ln of x. And then you write the derivative of ln of x right here. Okay? And the crucial thing is, because we're trying to explain that that's true, we'll pretend for a moment that we did not know that this is true. And we're just trying to discover what ln of x prime is. And this is almost it, because see, e to the ln of x, what's that? You can cancel e and ln, so that's just x. So if we have x times ln of x prime equals to 1, right? So what's that? If I divide by x both sides, we finally get that ln of x prime is 1 over x. Okay? So that's why ln of x prime is 1 over x.